Hey Algebra 2, this is Mr. Osborne. I'm going to be going over addition and subtraction of rationals. Just so you know, the first steps are obviously different from multiplying and dividing, but in the end we're still going to simplify and leave our answer in factored form. So if you guys remember fractions, if I have 1 plus 3, 1 over 3 plus 4 over 5, in order to add these two fractions, I would have to change these denominators so that they match, so that they're the same, and then I could add the numerators. So we're going to do the same thing with rationals. Okay? Now, if I look at this problem here, our denominators are the same. So we can go ahead and skip to the next, skip number 3, step number 3, add the numerators together. So now I have x plus 6x on the top, and 8x to the 5th on the bottom, and I can add those like terms on the top. 7x over 8x to the 5th. And now I can cancel like factors. So I probably should have said cancel like factors here as the step after number 4. So now what I'll do is I'll break it down. 7 times x over 8 times x times x times x times x times x, because there's 5 of them. And I can cancel out the like factors here. So I got 1x here, 1x here. And then I'm left with 7 over 8. And I have 1, 2, 3, 4 x's. So x to the 8x to the 4th. Okay, and I can't reduce the 7 and the 8 because there's no common factors between the two. Okay. Now in this problem, I didn't write in the steps, but in order to add and subtract a fraction with a whole number, that whole number needs to become a fraction. So I write 4 over 1. And then we need to make the denominators the same. So what I'll do is I'll multiply the one on the left by 6ab. And if I do it to the bottom, I also have to do it to the top. And now let's rewrite our expression. 6 times 4 ab over 6ab minus 4 over 6ab. Now I can add the numerators. 24ab minus 4 over 6ab. And now what I want to do is, as it says in step 4, is find a GCF, or common factor, greatest common factor, between every term in our rational. So it looks like I could probably take out a 2 from each of these numbers. And as far as the variables go, there's no variable that is shared between all three numbers, so I can only take out a 2. So let's just take out a 2. And I'm left with 12ab minus 2 on the top. And I take out a 2 here. So that's just 2 minus 2 times 3 times a times b. And now, cancel the like factors. Well, I only have 1, 2 on the top, 1, 2 on the bottom, and nothing else is a like factor. So then I just write out what I have left. 12ab minus 2 over 3ab. And then that's it. Okay, so now this next one. Now this next one, there's 2 fractions, but they have different denominators. So I need to make them the same. So in order to do that, I'm going to have to multiply this one on the left times the denominator on the right, and then I'll multiply the one on the right times the denominator on the left, which is 3. And I'll do the same thing to the top and bottom of both of these. Now, on the left, 4 times 4 is 16, and then a times b cubed, all over 12b cubed, that's our new denominator. And then on the right, 3 times 2a, which is 6a, and then we know we're going to have the same denominator on the right. Now we can add the numerators. So now 16ab cubed plus 6a, all over 12b cubed. And now again, factor out a greatest common factor between all the terms, not just the top or not just the bottom, but between all the terms in the whole rational. And it looks like I could take out, again, a 2. There is no common variable, so again, we can only take out a 2 here. So I'm left with a times b cubed plus, let's see, that would be 3a, all over 2 times 6 times b cubed. And the common factor we would have here is 2 again. And it looks like there's no other common factors, so we would just rewrite the rest of the expression. 8ab cubed plus 3 all over 6b cubed. Now on this problem, you'll notice that the denominators are the same. So we don't have to change the denominators here. All we have to do is add the numerators. So now I'll have x minus 1 plus 6 plus 1 all over 3x squared minus 12x. And now what I want to do is on the top combine the like terms. X plus 6x be 7x. And the 1's, oh, I apologize, this is actually 6 plus 1 here and here. So those 1's will actually cancel each other out. So now I'll just have 3x squared minus 12x on the bottom. And now what I want to do is factor out a GCF but among all the terms. Okay, so find a GCF or common factor between all three. And the only one I can find is x. So I have x times 7. And then if I take an x out from the bottom, I'm left with 3x minus 12. And then all I can cancel out is just that 1x on the top and the bottom. And then I'm left with 7 over 3x minus 12. Okay, now if I go up here to the right. Now, with this one, I say factor GCF in denominator. The reason I say that is because obviously the denominators are not the same, but it's a little different this time because we have a binomial here on the left and just a single term here on the right. And so what I'm going to do is I'm actually going to factor the left here so I can figure out exactly what I need to multiply times this 3 on the right. So now I'll rewrite this as n plus 3, and then I'll factor out a 3, and I can also factor out an n. And so now I'll have 3n, and I'm left with the n here, and then a 5 here. And then it's plus 2n over 3. And now I know that I have to multiply that 3 times n times the n plus 5. Okay? So now I multiply times n plus to n times n plus 5 on the top and the bottom. Okay, so now let's rewrite it. I have n plus 3 over here, 3n times n plus 5 over here, and then on the right I'm going to have 2n squared times n plus 5, and then I will have on the bottom the 3n times n plus 5. Now I'm going to combine the top, or add the numerator, plus 2n squared times n plus 5 all over 3n times n plus 5. And I'm also going to go ahead and multiply this here so that I can combine everything and see if I can find some like terms. Okay, so 2n cubed and then 10n squared, and then I left with n plus 3 over here. So in the end, I actually don't have any common factors between any of these numbers, because all these numbers have n, but this 3 doesn't. And as far as prime factors, there's really nothing else I can factor out, so that's it. I leave it as that. Now this last one. The last one, obviously the denominators are different, and so when you have a binomial on the left and a binomial on the right, you're going to multiply the binomial on the right times the binomial on the left. So I'm going to multiply this one times r minus 3 and r minus 3. And then I'm going to multiply this one times the binomial on the right. So r plus 3 and r plus 3. And so after I multiply that out, I'll have 3r plus 9 over r plus 3 and r minus 3 minus 3r minus 9 over the same denominator, r plus 3 and r minus 3. Now you might be wondering, where did I get that, the 3r plus 9 and 3r minus 9 in the top? Well, I just went ahead and jumped a step and distributed the 3 here and distributed the 3 here. Okay, so now when I combine them, the numerators, I'll have 3r plus 9 minus, now if I have a minus between the two rationals, I need to write a parenthesis because I'm going to have to distribute that negative all over that same denominator, r plus 3 and r minus 3. And now, distribute the negative. I have r plus 3r and, sorry, that's actually minus 3r, and then plus 9. And so now you'll notice that I have 3r and minus 3r, so those will actually, sorry, let me write the rest of the denominator. The 3r and the negative 3r will cancel each other out because it's 3r minus 3r. But then I'll have 9 plus 9 on the top, which will be 18 over r plus 3 times r minus 1, r times r minus 3. And there's no common factors between all those terms there in the factors, so that's what I'm left with.